Good morning everyone. This is Murali Krishna Senapati. Now today to start with hashing concepts. So in the last class we have discussed introduction of the hashing. So now today we will discuss about the hash functions. So we have known what is hashing, right? If you compare hashing and the searching techniques, then hashing is a special kind of method. So here when you go for searching, the time complexity, worst case time complexity of hashing is order of 1. So means if you search for a value which is available at the starting address and if you search for the value which is available at the last address, both will take same constant time. So anyway, let us start with the hash functions now. So in the last class, just quickly I am just saying, say hashing means, say when a set of key values are given which is to be stored, we will apply some mathematical some function which will generate the address, and in that address the corresponding value will be stored. Suppose in this particular example you can see, for 10, by applying some function, when it generates the address 1, means in the address 1 the 10 will be stored. Similarly 19 is generating 0, then address 0 19 will be stored. 35 is generating 8 and the address 8 35 will be stored. That manner we are going to implement the hashing. So what is the benefit of it? Whenever say you want to search for a value, suppose you want to search for 35, immediately when a person want to search for a value, say 35 it is going to generate at the time 8, directly you will go to the address 8 and you will fetch the data. So what is the time it will take? Whenever user want to search for a key value, the finding the corresponding address with the help of function and moving directly to that particular location, it will take the time. So as because it is able to find the corresponding address, it is not going to search in serial manner like in linear search. It is not searching in serial manner, rather it is not searching in binary search like in divide and conquer technique. Here it is directly finding the address and it is moving there to get the data. So that is why it is taking constant time. Whether you want to search for the starting value or you want to search for the last value, it will take a constant time. That is what the advantage of hashing. So for implementing that, we need to have a standard hash function which should always generate some address which should be unique. In this example, I have not taken much standard function, that is why the address are somewhere repeated. Say here 8 is given for 35, 62 also 8 is generated. Similarly for 59 4 is generated, 31 also 4 is generated. So it is not that much of standard. So we have to implement such a manner so that addresses should be unique. So here addresses should be unique. It may not be always possible. In rare case, whenever their addresses are repeated, during that time to handle that situation, there are again certain methods are present. So let us move forward to understand what are the hash functions available. So in our data structure, there are some important standard hash functions we will discuss, that is division method, mid square method and folding method. Okay, division method, mid square method and folding method. So first of all, let us discuss about what is a division method. So see here. So division method. So division method means what? Here we can read, choose a number m which is a prime number and m is greater than total number of key values. So we have to select a number m which is a prime number. So on what basis, what purpose we will select that number? That number we will use for dividing the key values. Okay, when we will divide a key value with a number, and if you generate the remainder value will be always less than that particular number. Suppose say 25 divided by 10, then it will generate a remainder. Let us say 10 to the 20, remainder is 5. 5 is less than 10 only. Okay, so something like that. So when m we will consider a prime number. Okay, and with that prime number when we divide here, then whatever the remainder will generate, that remainder will be always less than that m. So that is obvious. So because it is remainder will be less than the divisor, so Here what we are doing is we will consider that m such that which is greater than total number of key values. So why it is greater than total number of key values? Suppose if I will give m is a prime number, let us say m equal to 23, means all the possible reminders will be from 00 to 22. So totally 00 to 22 means 23 number of reminders it will generate. Okay. Similarly, if m equal to 103, then reminder will be maybe from 00 to 102. So based on that many reminders it will generate, means that m is representing that many number of addresses it will generate. Now here let us consider this example to understand better. See here, consider there are 68 employee details are there. Okay, in this example we have seen it is some sample data. Let us say it is totally 68 employees. Between there are some data we have not shown in this particular table. Okay, some in between some table we have presented. Now in this particular table, let us assume there are 68 employees. When there are 68 employees, we need a hash area, memory area, where 68 addresses should be present, and we should able to store this data. Minimum 68 addresses are required. So what we are doing here, we will choose m such that m must be greater than 68. M must be greater than 68. M is need to be, again it is a prime number. A prime number which is greater than 68. So that may be 71, that may be 73, that may be 70, 79 is a prime number. So like that. You can select a prime number which is almost greater than and nearer to that particular number of employees, so that the hash table can be generated and memory wastage also will not be there. Okay, so let us consider in this example, let me consider the m equal to 73. I have taken here, you can observe here, I have taken m equal to 73. Okay, so for this particular table I have considered m equal to 73, means 73. With that I will divide this number, whatever the reminder it will generate, that reminder will be the address to store that number. So similarly 1437 divisible by 73, whatever the reminder it will generate, that reminder will be considered as an address where 1473 will be stored. So like that we will be maintaining. So let me explain that. Okay, while dividing this, say this is my table and its corresponding discussions. See here what we have done here. Say when hash function is accepted by 1234 divided by 73, it generated the address, that is 66. 66 is the reminder. Similarly, when you divide 1437 divisible by 73, it is generating the reminder 50. So 50 is considered as a hash address for that particular key value. Similarly, for this particular key value, the address is 7, reminder is 7. 4678, reminder is 6. 5941, reminder is 28. Have you understood what it is mean? Means for every key value we are dividing with 73, we are finding what is the corresponding reminder. Now these are the reminders which we are considering as hash addresses. Now what we are doing is, you can see what we are doing is, now when the hash address, if it is my hash table, memory table, and here we will be storing the data, the reminder will be for 73 from 00 to 72. So that is the possible reminders. So means possible hash addresses are from 00 to 72. If it is started from, if it is the prime number is 73, that is m, then the address starts from 0, it will go up to m minus 1. Okay, because that is the total number of possible reminders. So that is the capacity of this particular hash table. Now in this table, suppose you are observe here the key address is 7 generated. After that address is 6 generated, means in 6th address the 4678 this key value we are storing. Similarly, in the 7th address 3438 will be stored. In the 7th address 3438 will be stored. Then 28th address 5941 will be stored. 28th address 5941 will be stored. Similarly, on the 50th address, okay, 1437 will be stored, and in the 66th address 1234 will be stored. So they are not storing in serial manner, rather as per the given input they are not storing, rather as per the address it is generated, in that corresponding address that key value will be stored. Okay. So what is the benefit of it? Again I am saying, whenever you will go for searching, let us say at certain point of time you want to search for a value. When you want to search for a value, suppose if you given 1 2 3 4 then as input, then compiler what it will do, it will find the corresponding whatever the address, then directly it will move to that address. It will not search serially, rather directly it will find the address and it will go there, it will read the data and corresponding whatever the employee name, address, all the details, okay, salary, all the details. Similarly, suppose if you give, suppose if user is inputting 4678, directly it is generating the address, it will go there, it will fetch the data. Means which data it is fetching, whether the data is fetched from this 6th address or the data is fetched from the 66th address, whatever it is not implementing in serial searching or any binary searching, rather directly you are able to find the address and directly you are moving to that corresponding address to find the data. So to search for a value which is available in the 6th address, how much time it will take? To search for the last value in the same hash table, it will take the same time. So it is constant time. Okay. So this is about our topic discussed about the division method. So I hope you have understood what is division method. Okay. Now let us understand the next hash function, that is folding method. Okay. So to understand, okay, that is mid square method. Now after mid square method we will discuss about folding method. Okay. So mid square method, it is the another hash function where again we are able to generate the address with some different approach. Here what we are doing is, when a key value k is given, okay, so when a key value k is given, we will be finding what is its k square, k into k square. After finding the k square, we need to identify middle position digits. Middle position digits, which digits we will assume, we will consider as the hash address. So h function, when it will receive the k, it is going to generate the address where, that is address L, where L is the middle value of k square. Okay, L is the middle value of k square. So to understand, again we have taken same 68 employee details. Okay, so to discuss. So see here in the 68 employees, if you have considered total number of employees are 68, then when you identify middle position digits, we will consider 2 digits or single digit. 2 digits we have to consider minimum. So because when suppose a large number is given, say if this is number is given, if you consider single digits as the address, the single digits possible digits are from 0 to 9. So that is totally how many digits it will, how many addresses it will generate. 0 to 9 means 10. So 10 addresses will not sufficient for 68 employees. So we have to consider 2 digit middle values of 2 digit elements, so that it will generate the hash addresses starting from 00 up to 99. So totally 100 addresses table will be there in this case. In the mid square method, 100, as per that 2 digits means 100 address table will be there. Okay. So definitely compared to division method, mid square method where memory wastage will be there. Okay. So anyway, if you consider 68 employees, then if you consider say you have 98 employees, 99 employees, then that is good. We can 2 digits also will be used properly. Okay. Now here what we are doing, we are considering 2 digit elements from the middle of k square. So what we are doing, just you can observe here. Okay, so for this particular key values, okay, for this particular employee detail, we are finding, okay, k square value here. Say 1 2 3 4 is given, h of 1 2 3 4 equal to 1 2 3 4 square value. 1 2 3 4 out to 1 2 3 4, we have got this particular number. In this particular number, say how many digits? 3 3 6 7 8 digit number we got. So actually we have got 7 digit number. I have included a 0 in the left side. If you include 0 in the left side, it will not change any value. It will not reflect in changing any value. It will be same. So we found h of 1 2 3 4 means 1 2 3 4 square value. Similarly, for each key value, we found the square values. Okay, so initially you can observe here 1 2 3 4 5 6 7 8 digits. So all we have represented in terms of 8 digits. Here already it is 8 digits, so 0 is not included. Here it is 7 digits, so I have included the 0. What I have done, I have ignored the from the left side 3 digits, on right side 3 digits, equal number of digits to identify the middle value, 2 digit middle value. Okay, so when it is odd number, then equally we can distribute. Even digits, then also left side 3 digits, right side 4 digits, like that we can ignore. Otherwise we can include 0 to make it uniform. So now we have identified the middle position digits. So for 1 2 3 4, the middle position of k square is 22. 1 4 3 7, it is 64. 3 4 3 8, middle position value 19. And for 4 6 7 8, it is 83. 5 9 4 1, it is 95. Means now in this particular mid square method, okay, what we are doing is we are finding middle position and we are identifying this as hash address. Okay, then in that address the corresponding key value will be stored. Now we can quickly look out this corresponding table how we have represented. Okay, so here we can observe in this table what we have done. Okay, now you can observe. So here, as because this is 2 digit numbers, our hash table hash address will start from 00. It will support maximum up to 99. Okay, because 2 digits. So means total number of addresses will be up to 100 its capacity. Now you can observe that 1 2 3 4 is generated the 22, means in address 22 the 1 2 3 4 is stored. Then 1 4 3 7 is generated 64, means in the 64 address 1 4 3 7 is stored. Similarly, say 3 4 3 8 is generated 19, so in the 19th address 3 4 3 8 is stored. Like that, say 4 6 7 8 is generated 83, so in the 83 address 4 6 7 8 is stored. And 95 is 5941 is generated 95, so in the 95 address the 5914 is stored. Now this is the hash table which we have implemented using mid square method. I hope you have understood this method also. So in this method what we are doing, again I am repeating that we are finding the square value of each key and we are identifying the middle value of it. That middle value we are considering as the hash address, and in the corresponding hash addresses that key values we are storing. This is the approach in the mid square method.